Okay, this is 3.3, quadratic functions and their properties. If you want, you don't have to, but there is a blank note sheet on PowerSchool that you could print off and take these notes on that note sheet. Otherwise, you can just take it on loose leaf. Yes, you're not crazy. We did skip 3.2. So we're going from 3.1 reviewing lines to 3.3 reviewing quadratics. You have been doing quadratics for 2 of your math classes. You did them in Algebra 1, and then you did them again in Algebra 2. So now it's time to really start showing that you really do have this note here. You really do know a lot about quadratics, and there's a lot to review in this section. So this first page is asking, what do you know about quadratics? And if I had you in class, I would say, okay, just raise your hand, what do you know about quadratics? And I would just go around until everybody was stumped. And actually, between everyone, I would usually get just about everything that I wanted to review. So the first thing I usually hear is, oh, there's the quadratic formula. I remember that, which is great, and you have to know that. So let's write that down. The quadratic formula, which we've been using this year already, that is x equals negative b plus or minus the square root. You sing this to Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you use that to solve quadratics. If you could raise your hand right now, what would you say? You might say, oh, Mrs. Seek, I remember the standard form of a quadratic. Don't you? Standard form. That is f of x equals ax squared in this like descending order plus bx plus c versus vertex form. Vertex form kind of has two names. It's vertex slash transformational. Okay. And the reason it's called vertex or transformational form, I'll tell you, f of x, it has this a again, but then it's x minus h squared plus k. Okay, so the reason it's called vertex form is the vertex, then you can see it right in that form. The vertex is at positive h, comma k. And then the reason it's also called transformational form is because you can see right here, this would be your phase shift, this would be your vertical shift, and then this would be your stretch or compression, okay? Let's see, what else? Speaking of the x value of the vertex is, do you remember this formula? I do usually have a couple people who remember it from year to year. The x value of the vertex is negative b over 2a. So then I always ask, okay, so if that's the x value, what's the formula for the y value? Trick question, there's not a formula. You just plug it into the equation. So you take f of whatever you get when you evaluate, negative b over 2a. Okay, what else? How about the graph of a quadratic? The graph of a quadratic is called a parabola. We've talked about that a ton this year. And then, you know, the x-intercepts of, and if I'm pausing this, or if I'm going too fast, definitely pause. The x-intercepts of a parabola are pretty famous. They have different names. We call them solutions. They are the solutions to the quadratic. They're also called zeros. And then the last name, not used as often, they're also called roots. Okay. So speaking of those solutions, a quadratic can have 0 solutions. a quadratic can have one solution or a quadratic can have two solutions. So I want you to take a moment and think about, what does the graph look like if it has 0, 1, or two solutions? Starting with 1. If it's only going to have one solution, that means that its vertex is right on the x-axis, and then this would either go up or down. But that's what one solution looks like. 2, it's just got to pass through the x-axis twice. Okay, that would be 1, 2. So then what does no solution look like? Well, if I were to put the vertex right here, I couldn't then open it downward, okay? And it have 0 solutions. It would cross twice. It can't touch the x-axis. So this has got to actually open upward, like so. Okay, those are a lot of important details, and we're going to get into those in some of these examples. Okay, so example 1, write in vertex form. I've given it in standard form right here. I want you to take this and turn it into this. And guess how we are going to do that? So you notice this has no factored form in it. This has a piece of it that is factored. Okay, so what we're going to do is we're going to use a great skill that we learned back in semester 1 called, I'm going to abbreviate it, completing the square. It's going to be the same technique. We're going to do a little bit different, a few different things, because it's not the same goal that we have. So vertex form, this plus 5 is going to be like the k value in vertex form. Okay, so what I'm going to do first is I'm actually going to factor out the common factor between the two terms with variables in them. So I'm going to make this f of x equals, factor out a 2. So I'm not factoring out the GCF, I'm just factoring out the 2 so that I keep it a quadratic. If you factor out a 2, it's no longer a quadratic to complete the square. Plus 4x, and then I'm going to leave a blank because I am going to complete the square there. So then if you remember completing the square in conic sections, you take the b value, and you take that b value and you divide it by 2, and then you square that whole thing. So it's always divide by 2 and square it. So you end up with 4. Okay, so far, hopefully that feels very similar to what we did last semester. Now, the difference is I don't have numbers or terms on both sides. I'm really just trying to stick to this side. So normally what we do is we'd say, okay, well, if I added that to this side to keep my equation balanced, I also have to add it to the other side. Okay, but actually we're going to do that, but in a little bit different way. So first thing, we didn't really add 4. We actually added 8. Okay, so instead of adding 8 right here to counteract that, another way to do that is to also subtract 8 from that same side. That makes it seem like you really did nothing. Okay, or you didn't do anything that affects the equation or changes it. Okay, so then this would be 2 times, if you factor this, that would be x plus 2 squared. And then minus 3. Okay, so then to graph this using transformations, the vertex, now this is where this is kind of tricky, the vertex is h comma k. So the vertex is actually going to be -2. So this is just like with conic sections. The value you pull out of these parentheses is the opposite sign. So it's -2. If it's positive, if it's minus, that value is positive. However, this is k. No matter what this is k. So k is -3. So I'm going to put my vertex at -2, -3. It's going to open upward because this is positive, and I'm going to try to make it look a little skinnier. That's a stretch. So Make it look a little skinnier than the actual parent function. Alrighty, next example. Graph the quadratic by finding the vertex and the x and y intercepts. So let's start with the vertex. Vertex, we find the x value first. X is equal to negative b over 2a. So a is negative 1 and b is negative 4. And there's actually not a c value here. We don't need it for the vertex formula though. Okay, so it would be negative 4 over 2 times negative 1, which would be 4 over negative 2, which would be negative 2. Okay, so that's your h. So in h, comma k, we have the h, and it is negative 2. Okay, so then the y value of the vertex, which is k, is equal to f of negative 2. So if you plug in negative 2, what do you get? You should end up getting positive 4 if you were to plug that in. Okay, so we have a vertex at negative 2, positive 4. So then x-intercept means y equals 0. So y is f of x, so we're going to have 0 equals negative x squared minus 4x. So we get to practice our solving skills. 4, that's a 4. So to solve this one, we're just going to factor it, and we're going to factor out a negative x. So if I factor out a negative x, I'd have x plus 4. So then by the ZPP, negative x equals 0, and x plus 4 equals 0. So x equals 0, and x equals negative 4. Now, the y-intercept is when x is 0. Well, if you plug in 0 here and here, what do you get? 0. We actually already found that. If you have an x-intercept of 0, that's also a y-intercept. Okay, so they wanted us to graph that parabola with this information. So we've got negative 2. Then we've also got 0, 0. We've got negative 4, 0. Okay, so we've graphed it with the vertex and the intercepts. Okay, make sure there's another video. Make sure you watch part 2.